As I mentioned in the science intro video, it's important to get an accurate estimate of the number of planets in the universe that would be capable of accomplishing what Earth has accomplished. Namely, that it has hosted and protected life throughout its progression for 4 billion years. Earth, its conditions, and its life forms have changed and produced advanced technological life. So here's the question. How many other planets in the Milky Way galaxy are capable of doing what Earth has done? In 2015, the BBC reported an estimate of over 18 million advanced communicating civilizations in the Milky Way galaxy alone, which implies that the number of planets capable of accomplishing what Earth did must be in the billions. Hey, why not? Who's going to question such a statement? Well, we are. Why is this an important question? If we accept the idea that there are billions of planets like Earth, then it does not matter what math and probability have to say about the likelihood of remarkable occurrences observed in life forms and circumstances on Earth. If there are billions of chances, then we can suppose that other dramatic occurrences failed to happen on other planets but succeeded here. With enough chances, anything can happen. But if Earth is rare, then mathematics and all other branches of science should be respected when it comes to considerations of life on Earth. Let's just highlight constraints that most of us can easily understand with regard to the requirements for a host planet to accomplish what has happened on Earth. Let's start with the NASA estimate of the number of stars in our galaxy from June 2015, perhaps 100 to 400 billion. Let's use 250 billion as an estimate. I know stars in our nearby space are more likely to have planets than not, but the vast majority of our 250 billion stars are in such densely populated regions of the galaxy that they cannot have planets due to the intense forces at work. An astrophysicist I trust suggests that only 2% of all stars in the galaxy have planets. For the sake of our estimate, we're going to be very generous and put the figure at 10%. Many stars with planets have only one planet. Today, a reasonable mean average estimate for the number of planets in a solar system is 5. So we can start with a generous assumption of 125 billion planets in the Milky Way galaxy. Let's now attempt to estimate how many of those planets are capable of accomplishing what happened on Earth, life from its earliest forms to intelligent, technologically advanced civilizations. Most of us have heard of the need for a planet to be in the habitable zone of its solar system. Most science sources, classrooms, networks, tend to estimate that 10 to 40% of exoplanets, planets outside of our solar system, are in their system's habitable zone. But what did NASA report in 2016 regarding what the Kepler telescope helped to discover? Of 1,284 recently discovered exoplanets, only 9 were in their sun's habitable zone. That is less than 1%. Let's give the benefit of the doubt and suppose that this is a low-end statistic from a sample of 1284. Let's use 2% of planets in their habitable zone. This brings us down to 2.5 billion planets in their habitable zones in this galaxy. Let's now apply a few more constraints that most of us can readily understand. We need at least 4 other very large planets in the same solar system in order to provide the gravitational force to prevent frequent strikes by asteroids and comets given any position in the host planet's orbit. It would be a very small percentage of solar systems that had at least 4 large, properly placed planets, along with an appropriately sized host planet that was located in the habitable zone. We also need a relatively thin crust on the host planet and a fairly narrow range for the percentage of water on the host planet. These additional requirements bring our estimate down to the neighborhood of 10,000 planets in our galaxy capable of doing what Earth did. Let's continue. We need an extremely large moon. For example, our moon-to-planet ratio is 52 times the mean ratio of other moons, and some planets don't even have a moon. Additionally, a planet needs radioactive elements for many reasons. Heat, tectonics necessary for developing life, just like the need for a large moon, and the sustaining of a liquid iron core to maintain an electromagnetic shield protecting us from exposure to rays that would otherwise sterilize the planet before complex life could develop. Since radioactive elements, which are produced by supernova, were not present in our universe until the 9 billion year mark, no planets forming prior to the 9 billion year mark of the universe could contain radioactive elements. Earth formed around the 9.2 billionth year. A host planet also requires certain characteristics of a sun. The spin rate of a planet in combination with other timings is also important. This brings the expected number of planets like Earth in the Milky Way to less than one planet. Thus, a planet capable of Earth's accomplishment is incredibly rare. The BBC's claim in 2015 that there are 18 million civilizations, let alone how many planets are capable, is a myth of epic proportions. There are several hundred more requirements for characteristics, composition, and circumstances in nearby space in order to produce a planet capable of accomplishing what Earth has accomplished. Over 900 requirements at the time of this video. I placed a link to these requirements below this video on the MovetoReality website. Is it mathematically and scientifically plausible to find even just one other planet in our entire known universe capable of doing what Earth has accomplished due to only natural forces and sources? No, not even close. There are only 10 of the 22nd stars in our known universe. We would need a whole lot more chances, a whole lot more lottery tickets, so to speak, to explain even one winner. We would need approximately 10 to the 1,000th planets. So without the billions of chances that allow us to ignore math and other sciences, we humans are quite the special species in this universe. Recognizing how rare we actually are then helps us recognize other issues. First, what about the argument that we are here, so there must be an explanation? Therefore, all of this is one big moot point anyway. Here is the conditional probability response to this statement. Of course it means that there must be an explanation. So what is more likely, random chance in nature or influence from a source from outside our space-time dimension? With no other information to go on, this question would be at a stalemate. However, as I have shown via the Jewish Tanakh on this MovetoReality website, we have been contacted by a powerful, concerned entity from outside of our space-time dimension. Thus, applying conditional probability, what would Occam's razor and basic probability tell us is the explanation for humans on Earth? God. The probability that we are here due to natural random chance is 0.0000, at about 1,000 zeros, 1. From this perspective, we can look to science to give us even more clues as to the existence of a God who has looked after us for billions of years. Start with our moon. Naturally, we must have collided with a smaller forming planet over 4 billion years ago. We needed a huge moon. It is too big for us to have captured it with our gravitational force alone if it simply passed close by us. We must have collided at a perfect angle and a relatively slow velocity in order for it to break off, be trapped in our gravitational pull, and do a few remarkable things. 1. Tilt us at an ideal 23.5 degrees. Think about it. How many planets have our perfect tilt, providing the widest range of habitable land on the planet for animals and preventing ice ages that might otherwise have a detrimental effect on life? And not only are we in an ideal location in the universe to see back 13 billion years in time, but our huge moon just happens to be 1/400th the diameter of our sun and 1/400th the distance from Earth to the sun. This has provided scientists the opportunity to learn about the universe during a perfect solar eclipse. Einstein verified the theory of general relativity based upon this. In the 1800s, we learned so much about the chemical makeup of the universe because of this perfect moon. None of the 60-plus other moons in our solar system would allow this knowledge to be acquired on any other planet. These signs of God's care are everywhere. We recognize that we cannot keep saying that billions of planets would lead to at least one incredible planet like Earth with so many coincidences. There are not billions of planets capable of what Earth did, let alone with such an amazing moon. Two great and easy-to-read books on the universe would be Rare Earth by Peter Ward and Donald Brownlee, and Why the Universe is the Way It Is by Dr. Hugh Ross. At any rate, the more we learn from secular scientific discoveries, the more we recognize the rarity of Earth and the existence of God. But given the bias on the part of us humans, it isn't always easy to get past the incorrect status quo groupthink in order to dwell in the realm of applying the scientific method and recognizing reality as it truly is.